this video, we're going to look at finding inflection points. Inflection points are going to be the place where our function changes concavity. Sometimes the second derivative test is known as the test for concavity. Long story short, what we're going to do is to find an inflection point, you're going to take your second derivative, set it equal to 0, and whatever value we get, that's going to be the potential inflection point. The reason I say potential is because sometimes something may not happen there. We may not have an inflection point. But if we do, if our function changes from concave up to concave down, so we're changing concavity or vice versa, then we do have an inflection point. So it's very simple, very quick. Let's go ahead and just jump into the problem. So we have f of x equals 3x cubed minus 6x squared plus 9x. And they want us to determine if f of x has an inflection point. So the first thing that I need to do is I am going to take our first derivative. So f prime of x equals 3x squared minus 12x plus 9. Now this is the same function I used in the video for utilizing the second derivative test to check for local min and max. And I'm gonna kind of go ahead and do that again just for time's sake. However, I'm going to go a little bit faster here. I know that to find my critical points, I can set this equal to 0. And we wind up getting the function that we can just set equal to 0 so that we can find our critical points. And those critical points are at 1, 3. Okay, the reason I do that is because I'm going to actually show you guys how we are changing concavity for this particular function. So I'm going to use those in just a moment. But for the second derivative test to test or to see if we have an inflection point, obviously I need to take the second derivative. So when we take the second derivative of this function, we wind up with 6x minus 12. Now, to see where we have a potential point of inflection, I'm going to set my second derivative equal to 0. So we have 6x minus 12 equals 0. Go ahead and solve for x. So we wind up getting x equals 2. So when I have that, we know that if we have a number line at 2, we have this potential point for something that is happening on either side. Now, I'm hoping that I am changing concavity, meaning I'm hoping I'm going from concave up or concave down to concave down or concave up. So what I want to do is I'm going to pick 2 points on either side of 2 and test to see what's going on. Well, I like this example because 1 and 3, they're actually our critical points. And so if we take our critical points and we plug our critical points into the second derivative, it's actually going to tell us if we are concave up or concave down at that particular point. So if I say f double prime of, say, 1, well, we get 6 times 1 minus 12. That's obviously going to give us negative 6, which means that here, when f double prime of a number is less than 0, that means we are concave, down. So we have a local max here. So if I plug in 3 into our second derivative, 6 times 3 minus 12, well, that gives us 18 minus 12 gives me positive 6. And whenever our second derivative is greater than 0, that tells us that we are concave up, meaning we have a local minimum. And I'm sorry, the video may cut off here a little bit, so I'll pull that up just a little bit. So I know what that tells me is at 1, we are concave down. We have a maximum there. And then at 3, when I plug in 3, we get a local min, so I know I'm concave down. And because when we have The change in concavity between 1 and 3, that occurs right there at 2. So that tells me because we are changing concavity, 2 is an inflection point for this function. So that is how we solve to see if a function has an inflection point. The fastest way is to find your second derivative. Take your function, get all the way down to the second derivative. Set your second derivative equal to 0 and solve. That's going to give you the potential for your point of inflection. Then, once you have that point of inflection, just take 2 different points on either side and just see if it is concave up or concave down. Now, it worked out very easily for us because our critical points were on either side. But using these number lines to test is a great way to do that. All right, so that's it. Testing for inflection points. I hope this made sense. I hope you guys feel a little bit stronger with it. Thanks for checking out the video. I'll see you next time.